skills for free. And the teachers to be trained on digital learning curricula across the continent. So in 2019, 3.85 million youth and 39,000 teachers participate. So what is the purpose of the coding, the training? As they said, it takes an empowered village to raise a child in the digital age.
Okay.
So ACW build a sustainable teaching capacity at the community level, and the power of together, and no child must be left out. Like every child must know how to code. We're trying to reach the unreached. So here is just a continent-wide success of coding, the African We Code. So it was launched in 2015. And then in 2016, the Google joined and Youth Mobile as partners. In 2017, the major international awards were given. 2018, it's cited as example of successful multi-stakeholder initiative in ITU Digital Skills Toolkit. 2017 also, 1.8 million youth engaged. In 2019, 87% of ACW survey response feel that the initiative in influential in advancing the adoption of coding into national curricula. Okay, to continue, like the coding is changing lives, like 3.85 million youth engaged, which 47 is girls. So more girls are encouraged to take part in coding also. 55,000 workshops were organized, of which were 42% were from rural areas. So we are reaching the unreached. Okay, but why the teachers are also involved in this is to prepare teachers and students for the future of work in almost upon us. We must continue to focus our collective effort on capacity building in order to drive long-term impact. Okay, when you are setting up your classroom, there are guidelines to follow. Gender balanced groups, so you must balance your gender. You must not just make girls only or boys. The number of boys are a lot than girls. You must balance it. Collaboration, equality, respect, taking turns, observing teachers, safe environment. You must make sure your students, your learners can code in a free environment. There's no struggling and so on. Active must give them a chance to ask whether the rules, non-theoretical rules, group dynamics. Step 2 of training season. Like the 2 steps of training season. The first one is computational thinking, and then the second one is to practice using a Scratch. So here we are coming in coding. We have programs. Programs, sometimes we call it a software. So a software is a set of instruction. It's like a group of instructions telling a computer what to do. A computer won't do anything until you tell it what to do. Okay, and then programming is to set up those, it's a process of setting up those instructions. Sometimes we call it coding in programming. Why learn to code? To develop logic and problem solving skills, improve attention to details, and it's fun. So for you, a computer, it only have the language that understands. The computer itself, like you can write in the language that you understand, but it converts those words into a binary language. The binary language is only zeros and ones. So the zeros and one you are talking about is this one. Like you can type in a class, hello, public static void in that language, but the computer transfers those words in zeros and ones. That's the only language the computer can understand. So we have some of the examples of programming languages. Those are the examples of programming languages. You can take any that you want to learn. So they all have ways of, or how to arrange their programming. Like here, when you're saying class hello, you can say it in a Java, but in a Python, there are other ways of arranging those words. Okay, now let's start with step one, computation thinking. Like for you to solve a problem must not take long to be solved, must be solved in an efficient way, in a logical way, and in a creative way. Here, talking about crashing or making a long solving problem short, like breaking big problem into a smaller ones. So we have about 4 of types of thinking. Decomposition. Decomposition is to break something into smaller parts. Let me say you want to go to the store. So you have to break it down, like which shop you want to go, what you want to go there, what time you want to go, how will you get there, and how much do you need. You just don't come from your home and then you go to the shop like that. You have to think where I'm going, what time, what do I need, and so on. So there is pattern recognition. Here you look similarities and traits and patterns. Let me say, okay, let's just stick to our going to the shop. Let me say you want to go to the shop and then you have an option. You have an option of walking and taking a cab. So you can say, no, I'll just take a cab up to here and then from there I'll walk. No, it's either you walk from here to the shop or you take a cab from here to the shop. So you choose the way it's similar. Okay, another one is abstraction, focusing on what is important and ignoring what is unnecessary. Maybe going to the shop today, it was not necessary. Okay, let me say you wanted bread and then you wanted it at the shop that is far and then you have to take a cab to there. So by the bread, you can get it at the shop that is near where you have to work and then save the money you are spending on the cab. So it's not necessary to go to the shop that is far just for a bread that you can get at a near shop. So that's how we had to think, like we had to solve a problem using a shorter solution. Algorithm design is to create a set of step by step. You just don't say you are going to a shop, but you didn't take the money, unless the money is not home. Or let me say a shop is far from an ATM, or maybe there's an ATM that is near the shop, but you are going to the ATM that is far. So you have to make, like, you are going to the ATM first and then go to the shop. You can't go to the shop and then go to the ATM because you need money to go to that shop. So you must step by step which one to come first and which one to go next and so on, not to repeat yourself. Okay. So digital skills, the skills that you are getting from this coding is to build confidence, have fun and interactive, develop computational thinking. Like here you will know how to solve problems, logical thinking, analytical skills have to be built, competitive and advantage. Here we mean, like, let me say you are creating a game. You are 4 groups and then every group is creating a game. You are going to sell that game. So make sure your game is competitive, like everyone want to buy your game. Future opportunity. We all, as students, when you're going to finish your school, so computer skills is a must for now. In all agreement, learning to code. Whether we are fighting climate change or going to space, everything moved forward by computers. Computers are taking over, let me just say technology in large. And we don't have enough people who can code, so you must make sure you go on that class where coding it's needed. When you are in a code class, then you are the respected one. All of my friends who have young siblings who are going to Korik or higher school, my #1 piece of advice, you should learn how to program. You must first tell yourself, I must know how to use a computer, especially I must create something a computer must do. Okay. And coding is a closed curricular subject. Once you master the basic and start writing code, you can leverage this to start solving a variety of problems from visual and other subjects. Let me say language subjects, physics, social study, biology, technology, maths, chemistry, and so on. The skills students learn from coding. Learning is a process. So you must just say no coding, it's stuff I don't want. One day you will want it. Collaborating with others, taking risk, and so on. So anyone can program. New tools like Scratch allow anyone to create computer program without learning complicated syntax. Time is money. We don't need to code from scratch one by one, while someone can come up with a program that you can use just to drag and drop and come up with your thing. So for now, let me give Mr. David so he take us through the practical how to use a Scratch to come up with a program. Our program, the program is to tell our computer what to do. Mr. David, the chance is yours. Mr. David.
Okay, Lucia, thank you for the chance. Yeah, don't remove your presentation. I'll be reading the first part from then.
Oh, okay.
Okay, thank you. Okay, afternoon, everyone. My name is David. I'll be taking you through the practical part for Scratch. Yeah, as Lucia said, coding is fun. Now we are going to try it and see if coding is fun. Okay, just to tell you, coding is one of the tools used to program. As Lucia said that a computer is dumb, cannot do anything, but needs some instruction to be put on it so it can operate according to the instruction. And Scratch is one of the language we use to code. As you remember the slide Lucia presented where he was showing us like C#, Java, those are other programming languages that we have. And the difference between those languages compared to Scratch, Scratch is a block building approach. While the other languages, you have to write your code yourself instead of drag and drop, the same as you do in Scratch. And the difference between programming language, it's only the syntax. Once you know to do something on a specific programming language, then if you have to move to the other programming language, then it's easier for you. The only thing that you will need is only the syntax on how to do a specific things on the other language. Okay. Then we say a programmer is a set of instructions that tell a computer or other electronic device what to do. It's just the same as robots. Robots were programmed or were given instruction to do specific things. And this is what we are going to try. Okay, Lucia, maybe you can just stop sharing so I can share my screen. Okay, let's get started. For those who are sitting in front of the computer, you can open Scratch if it's installed in your computer. And if it's not installed and you are connected to the internet, just go to the MIT website so you can do it online. Because this tool is a online based and it's a offline. You can able to do it offline if you are not connected, and you can also do it online. Okay, Lucia, can you just stop sharing so I can share my screen? Okay, thank you. Okay, I hope everyone can see my screen. Hello? Lucia, can you see my screen? Are you guys seeing my screen? Just unmute yourself, then you can answer me.
I can see you.
Okay, thank you, Mr. Daniel. Okay, let's start. For now, I'm going to use the offline tool. As I said, you can use this tool offline where you just download it, then you install it in your computer in case you don't have internet, or maybe you stay in the remote area where the network is not good. And to do it online, you just go to their website, scratch.mit.edu. Okay, this is their first page. Let me just sign out. I want to be on the home page. Okay, this is the home page. Once you type scratch.mit.edu, this is the first page. Then if you want to start using the tool, you just come where it says start creating. Once you come there, start creating, then Scratch will open. As you check here, then you compare it with the offline, which is opening here, it's just the same. There is no difference, meaning that maybe the online version is better compared to the offline. No, everything is just the same. Okay, for now, I'll be using the online one. Everything that I'm going to show you on this online based tool, you can also try to do it on the offline. It's just the same thing. Okay, if you check here on my left side, I have code. We have 3 tabs where the first one is saying code, then we have costume, and we have sound. Okay, all the codes, all the instruction that we are going to give to our computer or to our machines, we are going to take them from the left side here. And these codes or the instruction are being grouped according to their functionality. If you can see now, I'm under motion, meaning everything that has to do with the movement, we will find it under motion. And you have loops, you have sound, event, control, and others. Just go through. Okay, here in the middle, for me, I call it, it's a brain for the computer. And this is where we are going to put up the instruction of what we want the computer to do or our object to do. And here on my right side, we have a screen. This is where the result or the output, the instruction that we are going to give here in the brain of the computer, then we are going to test it. If our computer or our cat, which is sprite 1, is doing or is following the instruction that we give to it. The result will be shown here. Okay. Again, here down on the left side, you can also able to add the extension of something that you need to do if you can't find it here. Like the Lego, the video sensing text to speech. Remember, you can create a real application using Scratch. For an example, if you have a robot that you want to give instruction, you can also just put this extension Lego Boost. Then you can even connect your robot to your computer. Then you can start giving instruction. Then the robot will follow the instruction that you are giving it to it. Okay. Now let's start. As you can see, our sprite 1, which is a cat, is not doing anything because remember we say the computer is very dumb. Therefore, it needs instruction for it to perform something or to do something. Now, here we have our object, which is sprite 1. And down here, you can see these are the property for our object, which is a cat. You can give it a name by, let's give it a name Katie. You just come here, you type. If you don't want it to be showing here, you can just click here, then disappear. But in this case, we want it to be showing. Okay, you can also change the size. Like for now, it's 100. Let's make it for 150 and see. Once I make it 150 now, it has increased the size. But let's just put it back to the 100. You can also change the direction. Maybe you want it to be like this or any direction where you want your object or the sprite to be facing. But for now, I will just leave it to 90. Okay. To add another sprite, you can just come here, then you click. The tool itself normally have some sprites already within the program itself. Then it's optional to choose what you want to use. It's either an animal, they're also grouped, or you can use a people, fantasy, dance, and others. It's up to you. For this case, I'm going to choose a basketball. Then now, once you choose your sprite, then it appears again on the screen where the output of the result will be showing. And to delete it, you just come here where there's a trash icon. Then you just click on it. And the good thing about Scratch also, you can also able to upload your own sprite. Let me say, instead of using a cat, maybe you want to use your own image. You can just come here, then where it say upload sprite, then once you click on that, then this window here in the corner right down, there is something that we call. For us to change it, you just come here where it say backdrop, then the system or the tool itself already have some backgrounds or the backdrops within it. Then you just select which one you want. For me, I'm going to select the beach trio. Then as you see now, our background has changed. You can also upload, maybe you want to use the background of your school. Then you can just take a picture, then you can come here again. On top here, then you can just say upload backdrop. Then you choose or you go to the location where you save the image that you want to use as your background for your program, application, or a game. Then you just open it. Then you will see it here. But for now, for me, I will leave it on this. Okay. Okay, the other thing for you to maximize your screen, if you want to have it in full mode, you just come here on top here. Then once you click there, then it's on full mode. And to go back, you just come here again. Then you are back to the normal screen. Okay. The other part, like the costume sounds, are coming to it as we are going. Is there any question for me before I continue? Or if I'm fast, always just post in the chat, then Lucy will let me know. As we say, no one should left out.
Sorry, Mr. Dave. Yeah,
yes.
are the notes going to be prepared or sent to us? Some of the notes that we saw first by Lucia.
Oh yes, we are going to send you everything. You just send us an email requesting those things. Then we will send you.
Thank you.
Even the video is recorded. We are going to share it with you guys.
Thank you.
Okay. Okay. Again, if you check on the right side here, there is a sign in. Like the online version, it's always good to sign in. Then once you sign in, even in case of the power failure or maybe something happened to your computer, then you lost everything. The next time when you sign in, you will find all your projects that you were busy creating on your account. And if you are using the offline, you can still just come here where it say file, then you save whatever you have into your computer. Then once you save it, the next time you want to continue with your project, you just come here again where it say file, then you say load from your computer. Then you can select the project that you saved. Then you can continue from there. Doesn't mean that every time you have to start from scratch. Okay. Okay, now let's start and see if coding is fun, as we said. Okay, this our cat, which is sprite 1 now, but we name it to cat. We want it to move. and get the instruction which says the cat must move because we want our cat to move. Okay, I'm going to pull this instruction and put it in the brain of the cat. And to do that, just move your cursor or your mouse pointer on top of the instruction that you want. Then you drag. Then you move it into the brain of the cat. That's how you do it. You can try it. Okay. And to delete, we have two ways of deleting codes or the instruction they broke it in the brain. It's either you put your cursor on top of the instruction, then you right click, then this menu appear, then you select delete block. Or the other way you can do it by just drag it back to the code side. It's optional, it's up to you. Okay. Okay, now we have put up the instruction which says we want our cat to move. Let's just click on the instruction. Once you click on the instruction, you can see that the cat is moving. See? The cat is moving because now you have put up some instruction in the brain of the cat that your cat must move 10 steps. See? Okay, let me just pull it back. Then you put 100. You can also change the number, which is for now I'll put 100 and see. Now once I put 100, then I click on this instruction. Can you see now the speed has changed compare when we put 10 here. Okay, now our cat is moving because of this instruction. But now it's not always good to come in the mind of the cat. We want, once we click on something, then the cat must move. Therefore, we need to give the instruction which say once a specific key or once we click on something, then the cat must move. Meaning now we have to give the instruction which say that. Okay, I'm coming back to my code side. Then I'll just scroll down. Okay. Then I'll move this, then I put it on top. The reason why I put it on top, remember during computational thinking, we talk about algorithm, where you have to arrange your codes. That's what we mean by algorithm, step by step. Like for now, what we are trying to do here, we are giving the instructions to our cat saying that when the green flag, and the green flag is this one, clicked, then the cat must move 10 steps. Okay, let's just test it if it's working. You see, now once I click on the green flag, our cat is moving. But remember at the beginning, before we put up this instruction, when I come here, our cat is not moving. It's because the computer can only do something according to the instruction. Why we decide to put up this instruction, say when the green flag clicked, then the cat must move 10 steps, or you can change here, it's depend to you. Okay, now once I click here, our cat is moving 10 steps. Okay, but we don't want always to come here for the cat to move. We want the cat to move forever. Once we just click on the green flag, then the cat must start moving. Now we are going to give instruction to the cat which says the cat must move forever. Okay, Lucia, just check the chat for me. If there's a question, then let me know. Or if I'm fast, then tell me also.
Okay, I will
Okay.
also.
Okay, now we come back to our codes. Okay, just to get that instruction, say forever. Okay, now I'm going to get this, which is a function which say forever. And I have to put the 10 step inside this because we want, once you click the green flag, then our cat must move 10 step forever. It's a rule. Okay, let's test it. If our cat now is moving forever. See, once you click on the green flag, then the cat move forever, but is what? Disappearing from the screen. But we don't want the cat to be disappearing from the screen. Therefore, we need to put up the instruction which say, once the cat reach the edge, then it must bounce, it must come back. Okay, let's put up that instruction. Okay, if you test it and your cat disappear from the screen, like mine is showing the tail here, just put your pointer on top, then you drag, then you move it to the position where you want it to be. Okay, like mine, I'll just put it there. Okay, let's go back to our codes or the instruction. Since we say we want the cat, once it reach the edge, it must come back instead of disappearing. Okay, I can see we have this code, then we just put it under the move. This instruction is say if on edge, then it must bounce. Okay, let's just test it if it's working. See, now our cat is no more disappearing, but we have one problem. And that problem is that when the cat is coming back from the other side, it's upside down. But we don't want the cat to be upside down. Therefore, we are going to stop our program, and to stop the program, you just click on the green, on the red button here, then you stop it. Now we need to give the instruction to our cat that once it reach the edge, it must not come back upside down. Therefore, I'm going to take this code which say set rotational style to left and right. Okay, let me just pull it back again this side and test it. You see, now when it's coming back, it's no more upside down. It's because we have given the instruction which say the rotational style, it must be left right. Okay. What else can we do to our cat? Are you guys happy with the legs?
Are we happy with the legs?
Yeah, the way it's...
No.
Okay, then we need to give the instruction. As you check, the legs are just like sliding, but normally the cat's supposed to move on the legs. Now we are going to put up that instructions. Okay, just come back on our codes. Then we have this instruction say next costume. Okay, let's just test it and see. Now you can see that the legs are moving. Okay, when we say next costume, okay, let's just go back again here on top where we have code costume and sound. Now I'm going to go on the side of costume. Once I come here, we have costume 1 and we have costume 2. And if you compare the legs on the first one with the second one, they are different. This one are like these, and for the second one are like this. Meaning when we put up this instruction, say next costume, meaning our cat now is changing from this, where the legs are like this, to the second costume, where the legs are like this. And you can also able to edit, maybe if you want to move the legs this side, or you can change the color, you can still do that. Okay, if we come back here again, then we start. You can see now it's changing from one to the second one. Okay. Let's just stop it. What else can we tell our cat to do?
Make sound.
Okay. Now we want our cat to give sound. Okay, I'm just going to pull out this instruction. Then remember, I want the cat to give the sound before it start moving. This is the reason why I'm putting my code here on top. Before forever, because I want the cat to give the sound before it starts moving. Okay, since we say the instructions are being executed from top to bottom, meaning once we click the green flag, then the cat will play sound meow until it's done, then it starts moving forever. Okay, let's just test it. You see, I hope you guys add the sound. See, let me stop it again and test it. You see, our cat have to play the sound before it start moving, because the cat is just following the instructions given to it. Okay. Again, let's say we want our cat to say hello, my name is Katie, before it play the sound. You just come back to your code again. Okay, we have this instruction which says hello, but we want our cat to say hello, then it say my name is Katie. Okay, if you can see here where it say hello, you can edit. And to edit, you just move your pointer there, then you click on it. Then you can type what you want your cat. Because remember we say Scratch, you can use it also by creating your story, where maybe you have two sprites and those sprites are communicating or talking to each other. Now we are going to say the cat must say hello, my name is Katie.
Katie.
Okay. Now we are saying once we click the green flag, then the cat must say hello, my name is Katie for 2 seconds. This is a period you want this to be showing. Then after 2 seconds it disappears, then it plays the sound, then it start moving forever. Okay, let's just test it. You see, once you click the green flag, then the cat will say, hello, my name is Katie. Then you play the sound, then you start moving. Okay. Now let's add another sprite. And to add, okay, about the sound, okay, let's just come back here again. We have a sound. Once you click on sound, then the sound that you put up there appear here. You can do some edit if you want it to be faster, slower, or louder, softer. It's up to you. And also, you can also able to record yourself. These are some of the sounds within the program or the tool itself. Just play this one. Yeah, it's up to you. You can still add, or you can record yourself. Maybe you want your cat to say something, or you can upload also a song or any sound that you want to use in your program. Okay, let's just come back here. Okay, now we are going to add another sprite. Okay, just click on there, then you click on it. Okay, now I have added the basketball. Now we have two sprites. But remember, if you check here in the brain for this sprite, the basketball, the one we added, we don't have any instruction. Therefore, even though we click on the green flag, the ball is just on the same position because no instruction given to it. Therefore, we need to give some instruction to the ball so that the ball can also follow the instruction given to it. And to make sure that you are under a basketball, any sprite that you choose, it must show here. Like for now, you can tell that we are under the ball, in the brain of the ball, because the ball is showing here and is even selected here. But if you want to go back on the cat, once you click on the cat, then the cat now is showing here and is even selected here. Always is important to check where you are putting your instruction. Because remember, if we try to put up instruction for the ball, but we just put them under the cat, then don't expect this ball to follow the instruction that you set up because you have put them up in the brain for of the cat. Okay. I'm going to show you something. For an example, we just want to have the same codes on the basketball. And to copy the codes from one sprite to another, just come on top of your instruction, then you drag, then you move them on top of your sprite. In this case, it's a basketball. Once you drop them on top of the sprite that you want, when I come here, you will find those codes. That's how to copy the instruction from one sprite to another. Now, once we click this, the ball will also say, hello, my name is Katie, and give a sound and start moving. Because the instruction that we have for the ball is just the same as for the cat.
The cat.
Okay, but now for us, we don't want the ball to say hello, my name is Katie, and play the sound. We are going to delete this. And to delete, remember I say you just remove them. Then you right click, then you can say delete block, or you just drag them back. Then we just connect this. Now, once we click on these, on the green flag, you can see our ball will just start moving instead of saying hello because we have deleted those instructions. Okay. You can also come here where it say costume for the ball. Then you can able to add another ball here under here, or you can change the color. Yeah. Okay. Lucy, do you have any question on the chat before I continue?
There is no question yet.
All right. Okay. Okay. Everything I was showing you now is falling under the basic of adding the sprites, changing the backdrops. Now we are moving to the advance. Okay, for now, what I'm going to create, as I say, I want to create a game where once a cat touch the ball, then we must have some score here, which is increasing. And in programming, when you need to save information, you need to allocate or create a memory or a place where you'll be storing those information or the data. And we call that variables. Now I'm going to create a variable where I need to store the score. And to do that, if we come back to our codes here, you can see we have variables. You just come there, then you come where it says make a variable. Once you click there, then this window pop up. Then you have to give a name to your variable. For me, I'm going to name it scores. Then you have to choose if you want to use this variable for all sprites. When we say for all sprite, remember we have two sprites, which is a basketball and we have a cat. Or maybe you just want to have it on only on a certain sprite. But for now, we want to have it on all sprite. I'm going to choose all sprite, then click OK. Okay, if you come here on our screen, you can see that now we have something. This is a variable that we created. Because remember, we are saying we are creating a game where we want to have a score increasing once the ball touch the cat. Okay, now once we start, our score is not changing because we still need to give the instruction. We say if the ball touch the cat, then the score must change. It can be decrease or increase. It's up to you according to the instruction that you are going to give. Okay, let's just stop. Okay, now I'm coming back to my instruction here. Then there's this instruction say if then. This is a condition, meaning in this shape, I'm going to put up my condition. Then inside here, I'm going to put up the instruction of something which I want it to happen once this condition is true. Then if it's false, then whatever I'm going to put up here, it won't be changing. Okay, if you see here, we have a shape. And if you come to some of this group where like sensing or operator, you find this shape, some are over. Like for an example, if I take this and I try to put it in this shape, it won't go there. Meaning this space can only be filled with the shape of the same type. Okay, like for us, what we want if the ball touch the cat, then the score must increase. Now I'm going to get that instruction. It say if touching, okay, it is. Then I'll put it inside here. Now let's read our code. It say if a ball, because we are in the brain for the ball. If the ball touch the mouse pointer, then what? We need to put up the instruction of what we want to happen once the ball touch the mouse pointer. Okay, and what we want is that this variable we created must change by 1. Okay, let's just come back to the code. Okay, then we get that instruction which say change my variable to 1. Okay, now I'm going to test this if it's working. can anyone tell me why the score is not changing? Just unmute yourself, then you can.
Because the cat is not touching the ball.
Okay. Okay. Now I'm going to make the cat to touch the ball and see again. Okay, let me just change the direction for the ball to 180 and see. Okay, now I'm going to start. But still it's not changing. Why? But still the score is not changing, even though the ball now is touching the cat. Okay, let me just stop and tell you the answer. Okay, remember we say the computer can only do something according to the instruction given to it. If we come back to our codes, when we read, we are saying if the ball touching the mouse pointer. We are not saying the cat, but we are saying the mouse pointer. The cat. Then the variable must change by 1. Okay, let's just start it. Then I try to touch the ball, but still it's not changing. Why is not changing? But I'm still touching the ball. Mouse pointer.
Are we following?
Yes. Yes. Why is it changing?
Okay. Let me give you the answer again. Remember, when you create our variable, we give it a name which is score.
Yes.
But if you check here,
Yes.
under variable, there is my variable instead of scores. That's why this score is not changing. Because remember, we have renamed it to score. Now, let's try and change this and put score, variable that we created, and start this. Okay, now I'm going to move my mouse pointer on top of the ball. Can you see? Now it's changing.
Yes.
Once I touch the ball, then the score is changing.
Hmm?
This is the reason is because we are saying if the ball touches the mouse pointer, then the score, which is our variable, must change by 1. But what we want is that once the ball touches the cat, then the score must change by 1. Meaning we are going to change here. Where it say mouse pointer, then we put our sprite, which is cat. Now, okay, let me just move this one here on top. Now I'm going to start this and see. You see, now when the ball is touching the cat, then the score is increasing. Because it's what the instruction is saying. Okay, I'm going to stop it. Okay, now we want always when we are starting our game, the score to be 0. Not just to be like continuous where you end. Like for now, once I start here, to just continue from 88. But we want always, every time when you start your program, then the score must be 0. Therefore, we are going to give up the instruction which say set my variable to 0. Then remember algorithm, we want it to be 0 once you click on the green flag. Just after you click the green flag, then this must be set to 0. Okay. Do you think if I click on the green flag, this score will change?
No. No.
No.
No.
Why?
No. Because it's set my variable to 0, not
Yes.
scores.
Thank you. That's the correct answer. Okay, let's just test it.
Yeah.
Once I click on here, then the score is not changing. Because remember, our variable, we give it a name which is score. But once we put score here, then we test it, it will change. You see?
Okay.
Yes.
Yeah. Okay. And another thing, we can take out this code. Then instead of starting the ball by clicking the green flag, we want to start the ball by placing any key on our keyboard. And to do that, just come back to the events, then you select this instruction which say when space key placed, then the ball must do something. Like now, I'm not going to start here, but I'm just going to place the space button on my keyboard. Once I place it, the ball will start, but the cat will not start. It's because we didn't place the green flag. If you remember the code or the instruction that we give to the cat, it's only, the cat must only move once we start what? We click the green flag.
Flag.
And the ball must only start once we place the space button. That's why you find some games where you need to use either arrows to control to move left or right, up or down or something. Still, you can do it. You just come here where it says space, then you can choose. If you want to use an arrow or you want to use a specific letter, you can just set up. It's your choice. Okay, for us to start our ball, we need to place the space button. See. Now, when the ball touch the cat, then the score increase. As we say, you can create a story using Scratch where you have two people talking to each other. You can create your game or you can create anything. As we say, coding is the solution to everything. You can use coding or you can code something to solve a mathematical problem, or you can use coding to solve something on physical, accounting or something, anything. Okay. Lucy, what's the time now? Do I still have? Okay, I think the time is not on our side, and I think that's all I wanted to show you, unless if there's any question. And if you are failing to
Any
do
question?
something, if you come here on top, you can see we have tutorials. Once you click there, you can just go around and check up on how to do a specific thing. And if you are failing to do it, always be free to contact us, then we can try assist you where we can. And to save, let me say I want to save this project so I continue later. You just come here, wait, save file. Then you select save to your computer. Then you give it a name. I'm going to name it Katie. Always,
Mr. Dave.
it's important. Yes?
Hello. There's a question
Yes,
here from Elena.
I can hear you.
Yeah. Listen to the question.
Okay.
Read again. Speed again.
How do the instructions get there? Do I have to make them up or just I just find them there?
Mr. Daniel,
She
I think
asked
she's very far from the mic. Maybe she can come closer.
Come closer.
Yeah.
Come this side. Yeah. Speak.
How do the instructions get there? Do I have to make them up or I'll just find them there already?
Which
You hear the
instruction?
question?
Yeah. Which instruction are you asking? This code?
Yes, the code.
Yeah. Always once you just open up the Scratch, then, okay, let me just show you here on this one. Once you just open up the Scratch, this is the first page. to random. And for you, the instruction, you always find them here in the brain. You find it empty, and here is where the result or the output will be.
Thank you.
Okay.
Another question?
I have a question.
Yeah.
Are we just restricted to the option to the comments that are on Scratch, or can we
Are
make
we?
up our own? Just restricted to use the codes that are on Scratch.
Yeah, like for Scratch, you can only use this, or you can import some extension. If you can see, we have pen, music. Yeah, you can also have a keyboard or something. If you are good in programming and you want to make a big project, just import this extension, like the Lego Boost or Lego Education. Like for, you can have a robot, then you connect it to your computer, then you can what? Give it instruction, then you can see how your robot is.
Okay. Thank you. Thank you.
Yes. Any question? Okay, I was just showing you.
I have a challenge here.
Okay.
Yes, my learners can't have access to the computers due to the Wi-Fi strength here.
Yeah, what they can do, they can
Yes.
just download the application, the offline, then they can install it into their laptop or their computer. Like if you check here, I have installed the Scratch application. This is offline based. I don't need internet for me to code on this one.
Okay.
Yeah. They just need to download the Scratch application, then they install it into their computer. Then they can use it offline.
All right, sir.
Any other question? Okay, if you don't have any question, that's all I wanted to show you for today. Just a basic and some advanced thing like the score, which is a variable. You can still continue
Mr.
from
Dave?
here. Yes?
Mr. Dave, there is a question here.
Okay.
Good afternoon, sir.
Afternoon.
I just want to ask, sorry, sir. I just want to ask on this coding, is it the offline one? Is it possible to be sent to something so that it can be installed in an object way for it to operate according to the instructions that were set up?
Do you mean
regarding the
like
softwares?
if I save this program, can I share it with someone?
To share it with someone,
Yeah.
where it's like an object, where it have like it need the instruction for it to operate like an object, something like external things.
Okay, let me
Meaning,
just
can I
answer
put
the
it
way
in the
I
USB?
understand the question. I'm thinking maybe you are saying like for now, I have created this game. If it's possible for me to share this game with other colleagues. Is it like that?
Okay, the point is, for example, let me give the example of a scenario of like, okay, a robot.
Yeah.
When those robots at like road signs, they are electronic things. I hope they were given instruction to operate in that way.
Yes.
Yes. Then the question is, is it possible to design something from here on the scratch to operate like the way the road signs are designed?
Oh,
Or
okay.
that
Now
David?
I get your question.
Oh, okay.
Okay. Yes, Lucy?
I think he mean like to save what he had designed or what he had been coding and share, isn't it? Like to
Yeah.
save
Yes.
and share.
Okay. Like for Scratch, you can save a program and you need some programs to convert your project into an application so you can able to install it.
Okay.
All right. Then is it possible for us to get that application, like specific which application can able to convert the program?
Mr. Dave, are you
Okay.
there?
Okay. Sorry, just in a phone call. Okay. Yeah, I will try. From which school are you?
Nyangana Combined School?
Okay, I'll try get those resources and try to send them to you. Maybe you can just write an email to us, everything that you need, then I can try. Because like for AP Builder, we also have something like Scratch, which we call AP Builder, but that one was mainly made for mobile application. That one, you don't need a converter. What you do, you just create, once you save it, it's already in APK format. Like for you just to install it straight in your phone from there. But for this one, for Scratch, you need some specific things that you can able to convert it into that application where it can able to be installed in other things. Because if we just save it now, then meaning if I have to share this project with someone, that person must have Scratch installed on his or on her computer for him or for her to open this project. Hello? Hello?
Yes, David, we can hear you.
Okay.
No. All right, sir.
Yes, Mr. Dave said his answer.
Yeah,
Yeah. Do you have
David, so if they can just, if you just Google convert Scratch to, you can convert it to different things, HTML, exe, and what he was saying, APK. So yeah, you just need a converter to be able to convert it to any of those other files. So .exe, for example, is a Windows type of installation file for application on Windows. APK is for the phone. HTML if you want the code so that you upload it as a website, but you still need to convert it to all those forms, different forms that you might want to.
okay? And Nita, did you share the form in the chat?
Yes, I shared the attendance form. Can all the learners fill it in so that we are able to give certificates to everyone? And we also just need to know which teachers also attended. Then we are also providing certificates for teachers as well.
Nita,
Yes, sir.
is this attendance for each and individual learner?
Yes, sir.
Yes.
And the teacher's space is not there.
The teacher can also fill it in. We just basically going to look at all the people that filled in that form, and then we are going to give certificates to those people.
But there's no space for teacher because the age ends at 19.
I know. We still have to change that part. I would say just note it down somewhere, that you say where you
Yes.
get your school name, you say teacher or something, so that we just know it's a teacher instead of a learner.
Okay, so I need to fill in every learner individually and send the form.
And then you just say save. Every single time you save, a record is entered.
Okay,
Yeah.
all right. Where are you?
And can you please send us pictures of the learners? We just want to be able to showcase you and your school that you were attending. So please do send pictures as well. We'd appreciate that a lot.
With WhatsApp?
Yes, even on WhatsApp. Just you guys on your computers and you attending the session, yes.
Okay.
Okay, if we don't have any more question, I think I can stop sharing my screen. And Lucia, can you just put the presentation back?
All right. Just hold on a bit. Okay.
Okay, just okay, just go again, again, again. Okay, 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 just stop there. Okay, you can also get the additional materials by following the link there where it say African Code Week Media Resources. You can also able to get some material like for teachers that you can use in your classroom to teach just by clicking on this link. But like for now, it's difficult for you to click and it will take you there. You can request this presentation from us, then you can send it to you. So once you open it, you just come here, then you click on the link, then it will take you there. Okay. Can you move to the next slide? And again, we also have these links where you can get another information about codings. Remember, we also have girl coding camp where girls are
That's like the
coding.
contract.
Yeah. We also have some female roles model,
It's just that
everything, all
also
the
in terms
additional
of time now,
resources.
it was supposed to be
We
3
will
hours.
just send you this, then with your own time, you just click on this link, then you can read more about coding. Okay, next slide. Yeah, all these some videos where you can check about African Code Week, how people are talking about codings, all these links for additional resources and computational thinking. You can also check all these videos. And we also have this one like coding without a computer. There are also materials provided to teachers and learners on how to do if you don't have a computer. Doesn't mean that without a computer you cannot code. No, you can still code. Just follow this link, then you can catch up or get the information on how to code without a computer. And these are some of the coding lessons. You just click on those links. Like this was mainly for teachers. Okay, all these links you can get additional materials that you need when you are conducting your sessions.
Mr. Dave.
Yes, Daniel, we can hear you. Let me just see if Mr. David is here.
Yes, no, I want to ask Nita, can I fill, I'm unable to fill in the forms now. Can that be done later?
You can do it later as long as you do it before we send out. But yes, David, we can hear you.
Okay. Nita,
Mm,
what they can do, they must copy the link from the chat, because as soon as we stop this, then everything is gone in the chat.
okay. Yes, Daniel, and you can just send me a WhatsApp. I will also be able to send you the link of the form again, but I think I've already sent it to you.
Yes, now the filling in, can I fill it in later because learners are many?
Yes, they just you do have time. I think we will only start creating the certificates from next week.
Okay,
Yeah.
thanks. I'll prepare that.
Okay. Yes, David, you can go ahead.
Okay, I think we came to the end of our presentation. Okay, and before we go, I just want all of us to switch on our camera so I can take some pictures. Hello? Lucy, you can
Yes,
still
mine is
present.
on.
Okay. Let's just turn on our cameras.
Maybe can you stop sharing so that the view of the everyone can be on? Because right now we have the shared. Okay. Lucia, you can just stop sharing completely. Don't quit, just stop sharing.
Okay. And I can take a picture.
No, it's fine.
Okay, it's fine. Okay, thank you guys for your time.
Yeah. Thanks, guys. It was nice meeting you all.
Thank you. Bye.
Bye. It was nice meeting you.
Say hi, all of us.
Bye.
Bye-bye.
Bye.
Bye.
Bye. Please say hi now. Bye-bye. You can come say hi here. Closer.